So constructions. Constructions are methods of creating figures without the benefit of measuring tools. So when you guys use a compass and a straight edge, you're not using them because they have markings on them. You're using them as non-measuring tools. So even though a lot of times for my straight edge I use a ruler, I will never use the markings on the ruler, and you could use the side of your calculator, the side of your binder, the side of your book, the side of your house. It doesn't matter as long as it's a straight edge. That's all you need, but not the measuring part. So part of geometry is creating figures from these two tools, and if you ask your parents about it, they probably did constructions when they were in school too. And they're actually more of the fun things to do in geometry because it's kind of like art. Feels like art when you're done. So we're going to start with the easiest construction that we have, and that is duplicating a segment. So to do that, we're going to go ahead and just make a segment. Don't make it teeny tiny. Make it a few inches. And duplicate means we're going to copy it. So when you guys see the word duplicate, it means copy. So let's label this segment AB. And down here we're going to make the same segment, but we're not going to use our ruler to measure like we would in usual days. We're going to use our compass to help us. So we're going to start this construction with a point and like a ray that goes on, well past the point that we would need. So make it longer than you think you would need. And then I'm going to mark this point as A prime to show that that's A's new location. So to duplicate or copy a segment, I'm going to measure between A and B to see how long that segment is. So that shows me that AB is this long. And then I'm going to come down here to A prime, and I'm going to swing an arc that intersects that ray, but I'm not going to put a dot there. Because true constructions, you want to see exactly where they touch. And so this is going to be B prime, but don't put a dot there because it muddies it up. And that allows you to see the exact intersection for where the arc hits the original ray. So that's how you duplicate a segment. That is the most basic construction. We will be using that in some of the pictures. Okay, we're going to step it up a little bit. Now we're going to duplicate or copy an angle. Now I know you could take your protractor and you could measure the angle and copy it, but we're not going to use the use of measuring tools. So go ahead and make an acute angle. It could be, I mean, if you want it 90 or a little obtuse, it could be. I just think it's easier the smaller the angle is. And we're going to name this angle A. We are going to duplicate A to another part of your paper, but we're not going to use your protractor to do it. We're going to use our compass and straight edge. So over on this side of your paper, I want you to start with a point and a ray again. And we're going to label this angle as A prime. All right, now this one's a little more complicated. So I'm going to have you go to the original angle A and put your point of your compass on the original vertex A. And I want you to swing an arc that intersects both sides of the original angle A. It doesn't matter how open the arc is as long as it's hitting both sides. Now when you try to work with your compass, it's really best to not push your pencil. If you end up pushing your pencil, you'll get these squiggly lines that aren't straight. So either try to hold it like I am down at the bottom, or you can hold it at the top and swing it from the top. Some kids like to do that too, but just try not to push your pencil. Okay, ignore that little stray mark there that I just made. So take that arc that you just made on your original angle and come over to the A prime and make that same arc and make it really big because you don't want to have to go back and make it bigger. So make it a bigger arc than what you're expecting to need. Now this is the step that most kids forget. And this step is we are going to measure how wide open our angle is between those two intersections. So the two intersections that we got are from the original arc that we put on our angle. So I want you to measure how wide open that is. So So that's how wide my angle is between the intersections. So get that measurement on your compass so you know how wide open it is. And then you're going to go to the new angle that you're making, and you're going to put your compass on the intersection where those cross already. You already have one intersection. And then you're going to make an X to get your second intersection. So again, this is how wide open my angle is. Now I bring it over and I X the original arc. That's my second intersection. Then what I can do is I can connect my vertex through that X using my straight edge, and I have my new A prime angle. So again, if you got stuck, you make your original arc and you copy it to your new angle. You measure between the intersections and you bring that measurement over and you make an X on the original arc, and then you connect the vertex through the X. Now, at some point later, you'll be able to measure these two angles with your protractor and see how good you are. So if this one is 45 degrees, that one should be 45 degrees. And you can kind of see how accurate your picture is once you've done your construction. So that is duplicating an angle. Okay, the third construction we're going to do is what is called a perpendicular bisector. Now, we haven't really defined perpendicular bisector, so I'm going to tell you what this is. A perpendicular bisector is when you take a segment and you make a line go through the segment, and it's going to do two things. Well, it's going to be perpendicular, which is a 90-degree angle, and it's also going to make a midpoint because it bisects. So when you get done, you are creating a line that goes through the midpoint and makes a right angle to the segment that you originally had. Okay? So that's what we're going to make. So down here, we're going to make ourselves a segment. I'll do it over here so that you can see. And I'm going to label my segment AB. Please do not make your segment teeny, teeny, tiny. If you do that, then your construction will be teeny, teeny, tiny. It's really hard to do. So let's make this segment AB. We are going to find the midpoint, and we're going to make a line go through that is perpendicular at the midpoint. So it's not only going to bisect, it's going to be perpendicular. Okay, to do this, you're going to put your compass point at A, and you're going to stretch your compass at least halfway. So it can't be under halfway or it's not going to work. So at least halfway. I usually say about 3/4 of the way, but at least halfway. Now, I call this the football construction, and it's football season. Well, it was. Now, if you're going to go off the page, you're going to have to make it a little smaller. So you're going to swing an arc that goes above and below your segment, like a semicircle. Above and below. And then don't change your setting on your compass. You're going to go back to the other side and put your compass at B without changing your setting. You're going to crisscross the original arc that you did, and you're going to swing above and below again. So you should see two X's. And so I tell kids all the time, in order to have this construction get full credit, there needs to be two intersections, one above and one below. And then you're going to take your ruler and you are going to connect those two intersections. And you're going to see, I'm going to put arrows on the end to make it a line. We created a perpendicular bisector, and that's because it makes a right angle and it also cuts at the midpoint and gives us a midpoint. So why do I call it the football construction? Do you guys kind of see how it looks like a deflated football? So it's a oval shape, and those are like the threads on it. So it's the football construction, perpendicular bisector.